Hello everyone. Today we will practice questions related to combination and permutation. It's very important to distinguish between these two. Sometimes it can be challenging, but as we mentioned also in the lectures, it's really related to whether order matters or not. If you can answer that question right away, you can say, I should solve this question using permutation or combination. So let's go through the questions and discuss about the solution in details. So for the first question, suppose that there are 8 runners. So we have 8 runners. The winner receives a gold medal. The second place finisher receives a silver medal, and the third place finisher receives a bronze medal. So we are selecting 3 out of 8. The first one receives gold, second one silver, the third one bronze. So how many different ways are there to award these medals? If all possible outcomes of the race can occur and there are no ties, it means that for sure we will have a first place, second place, and third place without any problem. Like we don't have 2 winners at the same time, it doesn't happen. And all of the runners have the same chance to be the winner. So generally we have 8 runners and we are selecting 3 out of them. The question that you should ask yourself in order to know whether this is a combination or permutation case, whether does it matter if the first person is selected first? Does it mean, for example, if the first one passes the line, because we have 8 runners, so if the first runner passes this one the first time, passes it faster than others, does it matter? For example, this one passes next and this one should get bronze. Yes, there is a difference between, for example, the first one who passes the line and the third one, because this one receives gold, this one receives silver, the third one receives bronze. So what we can say order matters. So when order matters, we should use permutation. So in order to write the complete solution, I should write the formula related to permutation phase first. So you are selecting R from N. So you should know about this formula, N factorial, N minus R factorial. So please write the formula first and then assign the values to it. So I know N is equal to 8, R is equal to 3. It means that I should calculate 8 factorial over 8 minus 3 factorial, which is 5 factorial. So this implies that the permutation 8, 3, or selecting 3 out of 8 will be 8 factorial over 5 factorial. And you already know how to calculate it, right? So it means that 8, 7, 6, and 5, 4, 3, 2, 1, or 5 factorial. So you can eliminate these two together, and what you have at the end is 8 multiply 7 multiply 6, and you can write the final answer. So this is what we call a complete solution for solving permutation and combination cases. Now let's go through the second question to see how we can deal with that. So how many permutations of the letters? So we have how many letters here? 1, 2, 3, 4, 5, 6, 7, 8. Contain the string ABC. So it means that these 3, we can consider it as one string. It means that here, ABC, I can consider it as one string. It means that now instead of 8, I have 6 number of cases, okay? Because S, D, E, F, G, H. Now I have 6 cases instead of 8 cases. Now there are 2 ways that we can solve this question. One way is to use the basic counting method and use product rule that we talked about it before. Like we have 6 cases, because you can consider ABC as a block, consider it just as a string, and that's it. So these are my possibilities. I have 6 letters. So in the first one, how many possibilities do I have? 6, because I have 6 options. I can put E, F, any of them, or S, and S represents ABC. So for the next one, as soon as I've chosen one of them, let's say you have chosen D. So D cannot be selected for the next one. It could be either ABC, E, F, G, or H. So I will have 5 possibilities, then 4 possibilities, 3, 2, and 1. In another word, you will have 6 factorial possibilities, okay? So this is one way to deal with that. Another way is to use permutation. It means that you have 6 letters, because now we are behaving to ABC as a letter. The whole string, we call it a letter now. So you have 6 ones, and you are trying to take 6 ones also out of it. Okay? So we know that order matters, because if you, for example, choose, let's say ABC, let's say this is 1 letter, then D, F, E, G, H. Okay, these 2 strings are now different from one another. See, order matters. And that's why when order matters, you should use permutation, not combination. So again, you write the general formula for permutation here. So you already know how to write the general formula from the previous example. So what we have now is 6 out of 6, which means 6 factorial, 6 minus 6 factorial. So you will have 6 factorial, 0 factorial. What is 0 factorial? You know this is equal to 1. So that's why we will have 6 factorial at the end, and you see you reach the same answer. And in the exam, please calculate the final result too, okay, because you have calculators, so write the final answer as well. Don't show me such a curly line. It is just for me showing you that you need to provide the final answer, okay? Don't put such a sign. It doesn't have any meaning, okay? So let's go through the next one. A group of 30 people have been trained as astronauts to go on the first mission to Mars. How many ways are there to select a crew of 6 people to go on this mission, assuming that all crew members have the same job? So we have 30 people, and we are trying to select 6 of them. N is equal to 30, and R is equal to 6. So as you can see, for both permutation and combination, we are looking for N and R at the beginning. This is not V, by the way, this is R. I'm trying to write it using mouse, so it's not that much clear. Anyway, now I should ask myself whether this is a combination or permutation case. So order matters or not. If the first one, for example, out of these 30 people is selected, I don't know, name him Mr. A, for example, then Mrs. B is selected, Mr. C selected, and I will select 6 of them. Does it matter if this person selected first or in the third one? Does it matter that this one selected here or first one? Does it any priority between these two guys who were selected in this crew committee? Actually, no, there's no difference, because we are not giving, for example, this guy more salary comparing to this one. All of them will be considered as the crew for this mission. So that's why order doesn't matter. When order doesn't matter, you should consider the combination, not the permutation anymore. Okay, so 6 out of 30 we should calculate. And don't forget to write the general formula before that. So let me write it here. NR is equal to n factorial, and here n minus r factorial. So until now, this is the same as permutation. What is extra is r factorial, because we are decreasing the number of possibilities, because there is no difference between ABC or BAC or CBA. It doesn't matter, the order doesn't matter. So we should divide it so that we will have at the end lower number of possibilities. So don't forget to provide the general formula. Then based on that, you could say, okay, n is equal to 30, r is equal to 6. So what I have is 30 factorial over 30 minus 6 factorial multiplying by 6 factorial and provide the final answer. Okay, so I think this one was pretty clear. Let's go through the next one. Suppose that there are 9 faculty members. So from the beginning, I know 9 faculty members, but here we have 2 departments, and one of them 9 from mathematics department and 11 in the computer science department. Okay, so I have 2 cases. For N1 is 9 and N2 is 11. Now, what's the question? How many ways are there to select a committee to develop a discrete mathematics course at the school if the committee is to consist of 3 faculty members from the mathematics department and 4 from the computer science? Okay, so we are selecting 3 from mathematics department and 4 from computer science. So I will have 3 from mathematics and 4 from computer science. So at the same time it should happen, you see, and so at the same time I'm selecting 3 from mathematics departments and 4 from computer science. This is a simple product rule. There is no intersection between them. If there is an intersection between 2 departments, then in that scenario we cannot use just simply product rule, because we know that there is no faculty member who is at the same time in the mathematics department and computer science department. This part we don't have any possibilities. So when you want to show it in Venn diagram, they are totally separate, you see. So they are disjoint, as we call them. Whenever this is the case, you can simply use product rule. So it means that I should deal with this one first and then this one. By using product rule, I can just multiply the possible ways together and find the final answer. And before that, you should ask yourself whether this is a permutation or combination question. So in this committee, does it matter if someone selects to be selected first or not? No, it doesn't matter. If you are inside this committee, you will have the same privilege as others. So in that scenario, order doesn't matter. This is a combination question. So first, provide the formula related to combination. You already seen it in the previous question, so provide the general formula. And then deal with it using product rule. It means that, by the way, you remember, instead of this, I can also show it like this, right? So in the product rule, easily I can calculate it like I'm selecting 3 out of 9 from mathematics department, multiply it by, when there is no space between them, this is multiplication. So 4 out of 11 from computer science, and this is the answer. Okay, so in order to write the final answer, you should know about the formula related to combination, which you show here. So now assign the value. It means that 9 factorial over 9 minus 3 factorial, 3 factorial inside the parentheses, multiply by 11 factorial, 11 minus 4 factorial, and 4 factorial, and find the final answer. Okay, so for combination and permutation questions, as you can see, it's very easy. But if the problem gets a little complicated when we are using different things that we know, for example, here we combined our knowledge about product rule with combination. So it means that you need to have more practice so that when you face more complicated problems, when we are combining the things that you know together, then you will be comfortable with that. That's why please go through the examples, especially with the solution ones in the book, so that you see various examples related to permutation and combination, because as I told you, it could be tricky. And also try to solve the questions that they are at the exercise part of the book. Go through them as much as you can and be strong, so that you will know more about combination and permutation more and more, because it needs practice. It's not, it looks very easy, and it is easy, but for sure it needs practice. That's why please go through them, and if you have any questions, please let me know. Okay guys, also for this assignment, if you have any questions, let me know in the public chat.